Here in this video, we are solving a NEET 2024 questions that appeared from Ray optics. Look at this first question. A light ray enters through a right-angled prism. You mean to say angle of the prism is 90 degree through a angle of incidence of 30 degree here. That means I1 is given as 30 degree. Here the angle will be R1, that is not known for us. We can say at first surface mu equal to, that is mu prism material with respect to surroundings equal to sin I1 by sin R1. Mu prism is mu surroundings is vacuum, that is equal to 1. Sin I1 is given as sin 30 and sin R1. That's one equation that we can use as with the given data. Travels through prism parallel to the base. He mean to say it is parallel to the base like this, means prism is in minimum deviation. Prism is in minimum deviation. When the prism is in minimum deviation, angle of the prism is actually R1 plus R2, but under minimum deviation we can write angle of the prism is 90 R1 plus, look at the R2, it emerges parallel to the face like this, it emerges out. That means here the angle of emergence I2 is 90 degree. This particular angle of incidence, which we call it like R2, is critical angle then. So A equal to R1 plus R2, but R2 is the critical angle 90 degree. So R1 is 90 minus C. Once when you say R1 is 90 minus C, you can rewrite this equation now as mu by 1 equal to sin 30 by sin 90 minus C. So mu equal to sin 30 is by sin 90 minus C is cos C. I need to know what's the value of the cos C. For that, we can write at second surface, at this surface, as the light ray is grazing, we can write mu equal to 1 by sin C. So sin C equal to 1 by mu. Cos C can be written like square root of 1 minus sin square C. That's 1 minus 1 by mu square. That is mu square minus 1 by mu square. That is mu square 1 by square root of mu square under square root is mu. That is cos C. Here you know the cos C, mean there is a term cos C. We can substitute it back in that place. What happens in that case? That implies from this equation mu equal to sin 30 by, in the place of cos C you can write root of mu square minus 1 by mu. That implies mu equal to mu sin 30 by root of mu square minus 1. This mu and mu will cancel. So 1 equal to sin 30 is 1 by 2 of mu square minus 1 under square root. So mu square minus 1 under square root is 1 by 2. Mu square minus 1 is 1 by 4. Mu square is 1 by 4 plus 1, that is 5 by 4. So mu equal to square root of 5 by 4. That is square root of 5 by 2 is the refractive index of the prism. That's how we solve. So while solving this problem, we learned a lot of concepts of prism actually. Look at the second question. A small telescope has a field length of focal length 140 centimeter, and then we have an eye length of focal length 5 centimeter. Magnifying telescope when the distance of the object is long, that is infinity. In that case, magnification is FO by FE for a astronomical telescope. That is 140 by 5, that is 28. So the answer is 28. That's how we solve this problem. Thank you for watching.